Hey, welcome back to your favorite technical mathematics class. We're going to look at functions, function notation. Let's talk about what a function is. A function is simply a relationship. You can have a relationship between any two variables that you want, where you have, for every input, there's exactly one output. So a lot of the times in algebra, you'll say for these functions, for every x, because x is usually your input that they use for the input, there's exactly one output y. So for example, like this is a function. For every input, it doesn't matter what you put in for x here. Like if you put in the number 3, 2 times 3 is 6, you'll have one output, and the output is 6. Right? So for every input, for every one that you put in, there's only one that comes out. For every x, there's only one y. Well, this x here in this case is called our independent variable. Not only is it the input, it's also the independent variable. And the output, which is dependent on the independent or input, is called the dependent variable. Okay, so the dependent variable is what comes out. So here's a formula. The area of a circle is pi times the radius squared. Who's the independent and dependent variables? Well, the area depends on what your radius is. So here's your input. So whatever you put in for your radius will determine your output. So that's your independent variable. Will determine what your output is. In other words, what the area of the circle is, right? However big this radius is, will determine the overall area of that circle. So the independent variable is the radius, the dependent variable is the capital A for area. So function notation, when you have function notation like this, y equals negative 3x squared minus 2x, this is just a f of x is simply a nickname, I should say, for y. First of all, it should be known that this is a nickname. But this is saying, what this is saying is it's telling you to input something in for x. Like for instance, if we input, let's say 1, this is saying find the functional value. This is saying find the functional value, find y, because f of x is y, when your x is 1. See how your x is 1? So it's telling you input 1 for x and find what your y is. So you go over here, you input 1 in for x. So negative 3 minus 2 is negative 5, and it looks like you get negative 5. So the functional value, the y value in other words, is negative 5 if you put 1 in for x. So when it says express the following equations using function notation, so this first one, that's all you got to do. You got to say f of x equals negative 3x squared minus 2x. Here you have p's and r's on the next one. So p equals 13 plus r. You can just rename that as f of r, because r is your input, equals 13 plus r. Or you could even name it p of r. It doesn't have to be f every time. But let's use some function notation here. So we've got f of x. Again, f of x just a nickname for y. It's 3x squared. And by the way, a lot of times students, well, why do we even use this? Function notation is a very concise and neat notation that the further you go into the mathematics, like you get into finding inverses and finding derivatives of functions in other courses, and the function notation is very handy because it's a nice concise notation that says a lot, that's useful in those other courses for other things to do with a function, such as finding inverse or taking a derivative. So that's why we introduce it. So here we're plugging 0 in for x, and that's all we do. Make sure you do the exponent first. So 0 squared is 0. 3 times 0 is 0. 0 minus 2 is negative 2. So f of 0, in other words y, is negative 2 whenever x is 0. Next one asks us to do it for 1/2, f of 1/2. So now we plug 1/2 in for x. So now we got 1 squared over 2 squared, so 1 squared is 1, 2 squared is 4, and now we got 3/4, multiply across there, minus 2, well this is 2 over 1, so get a common denominator, So we got 3 fourths minus 8 fourths. So 3 minus 8, negative 5 fourths on that. Let's do the next one here. We got f of negative 2. So now we plug negative 2 in for x. 3 times x, which is negative 2. So we got negative 2 squared. It's negative 2 times negative 2 is 4. 12 minus 2 is 10. So f of negative 2 is 10. Do it for these other ones here. So this is our function notation. You can erase this here so I get some room. So now we got f of t equals 3t minus t cubed. The first one we're plugging in is 1, f of 1. So 3 times 1 minus 1 cubed. 3 times 1 is 3. Make sure you do the 1 cubed first. Minus 1 times 1 is 1. 3 minus 1 is 2. So f of 1 is 2. So y equals 2 whenever the t is 1. Let's do it for f of negative 2. Now we plug negative 2 in. 3 times negative 2 minus negative 2 cubed. Again, negative 2 times negative 2 times negative 2 is negative 8. And then we got 3 times negative 2, negative 6, minus the negative 8. So you get negative 6 plus 8. So we got 2. Over here, h of v. So now we're going to go h of negative 3. It's negative 3 plus 1 over negative 3. Well, that's negative 9/3. I got to get a common denominator, minus 1/3. Take that negative up, so we got negative 10/3. It's h of negative 3. H of 0. So now I got 0 plus 1 divided by 0. Well, you can't divide by 0, so this is undefined. And finally, you got h of a. So a goes in for v. A plus 1 over a. And that's it. You stop right there. Or you get a common denominator, probably even better. Just times it by a to get a common denominator. A squared plus 1. Now it's all over that common denominator of a. Either one of those will work. You just plug in a in there for v. Alright, the domain and range. Well, the domain is a set of all input values for a function. So for this first one, f of x equals the square root of x minus 3. And if you think about the square root of x for a minute, what numbers can you take the square root of? Like you can take the square root of 0, that's fine, it's 0. You can take the square root of 1, that's fine, that's 1. You take the square root of 4, that's 2. Square root of 9. So you take square roots of zeros, positive numbers, but you cannot take the square root of like a negative number. You can't do that. So whatever you have under the radical, this x minus 3, to get all that together, has got to be greater than or equal to 0. And that's going to tell you what your x value has to be. So you add 3 to both sides. You can solve this. X has always got to be greater than or equal to 3. That's your domain. Your domain is x has got to be greater than or equal to 3. And if you think about the original function here, you have to have a 3. You can't have anything smaller because 3 minus 3 is 0. That's where you can start. But if you have that being a 2, 2 minus 3 is negative 1. You can't take the square root of negative 1. So that's how you find the domain of a square root function. Similarly on this second one where you have f of x, square root of 2x plus 5. What's the domain there? You say, well, everything underneath the radical has got to be greater than or equal to 0. You subtract 5 from both sides. Divide by 2 both sides. So any number that's greater than or equal to negative 5 is your domain on this. Anything greater than or equal to negative 5. How about this one right here? F of x equals 1 over x. You want to think about, well, what can x not be? I cannot divide by what? 0. Anything besides 0 is fine, but that's our domain. Anything except 0. The next one here, y equals f of x equals 3 over x minus 5. So here you think, well, I can't divide by 0, So who's the problem child? Well, x can't be 5, because if x is 5, I'd have 5 minus 5. So that's my domain on that one. Other than that, x can be anything. All right, let's go back to the relation when relations are functions. So we're thinking about the function definition, which says a function means for every x there's one y. For every input there's one output. So if you look at this relation, you know, you have one, these are our x's, here's our y's. Oops, one, oh my goodness. 1 goes to 2, here's my y's by the way. 1 is projected onto 2, 3 is projected onto 4, 5 is projected onto 6. So you say, is this a function? Well, for this x, there's one y. For then x of 3, there's only one y. For an x of 5, there's only one y. For every x, there's only one y. So yes, this is a function, this first one. How about the next one? 1 goes to 2. Here's my x, here's my y. 3 goes to 2. Well, for this x, there's one y. For this x, there's one y. So yes, this next one's also a function. How about the next one? 1, 2, 1, 3. 1 goes to 2. Here's my x, here's my y's. 1 goes to 3. Well, for this x, there's two different y's. That's the problem. 1 goes to 2 and 1 also goes to 3. So this third one's not a function. Can you see that? That's not a function. You can have them in equation form. So you got the y equals x squared plus 1. And if you think about that, it doesn't matter what you put in here. Like if you put 1 in, it's going to spit out an answer. 1 squared is 1 plus 1 is 2. If you put 2 in, 2 squared 4 plus 1 5. Anytime you put a number in, it's only spitting out. For every input, there's only going to be one output. So this one's going to be fine. Yes, that'll be a function for you. Similarly on this one, where you're going to run into problems is when you have a y that's to an even power, not a y to a 1 power like those other ones. If you have y to an even power, so 9 equals x squared plus y squared. 9 equals x squared plus y squared. In fact, if you solve for y, so y squared equals the 9 minus x squared, and you square root both sides, what you have is, when you put something in for x, like 0 for a minute, let's plug 0 in. 9 minus 0 squared is 9. Square root of 9 is 3. What happens is when we plug 0 in for x, we got two different y values. So this is a no. So when it's in equation format, if you ever see a y to an even power, that thing's not going to be a function. Okay. All right, thanks for watching. See you next time.